so people who are attending can discuss the ways that they think these technologies could potentially be used to support teaching and learning at CSU. We've chosen this format in the hope that busy academics and professional staff can squeeze in at least half an hour, a couple of times each week, to attend these presentations. And I'm pleased to say that some of our expert presenters for this season are CSU staff members, which is an indication that we have academics and disciplines at CSU who are leading innovation and application of some of these technologies in this space. I'm pleased to introduce the presenter of today's launch, none other than our very own Tim Claptor, who is the online learning technology leader in YourMagine. And Tim's presentation is called Welcome to the World of Mixed Reality. And this will provide an overview of the topic, laying some of the foundational concepts and technologies and providing some examples of how we can rethink the world around us using these new technologies. So please feel free to use the chat to share ideas, comments or questions throughout Tim's presentation, which we can draw upon in the Q&A and general discussion time in the second half of this session. So over to you now, Tim.
Okay, thanks for that, Lynn. Just a reminder, if you want to mute yourself, might save some embarrassing kind of phone calls or pinging noises. Yeah, so what I'm working on today is doing a bit of a kind of overview of what mixed reality is, and some of, I guess, the ideas behind the technologies. I think there's a lot of kind of focus on the technologies themselves. I guess what I wanted to do is, I guess, do a bit of a deeper dive into what were some of the kind of driving ideas behind this. And I think once you kind of get into that space, it kind of opens you up to rethinking about what are those possibilities and the applications to education and learning. So this, I guess the foundational concept is just this idea of having two separate kind of spaces and realities. We've kind of got this virtual one, and then on the other hand, this kind of physical one. And, you know, if you break it down, essentially what we have is what we can imagine in our heads and then what actually exists. And there's always been this kind of duality existing. You know, it kind of goes back to what is essentially kind of being a human. And, you know, but we've also sought to kind of talk through this, to kind of share those virtual things, those things we imagine. We want to share them and we want to get them out of our head and be able to kind of talk through them, to discuss them, to kind of expand what we do. And we've always kind of sought to do that. And, you know, one of the earliest ways is to just do the storytelling of telling stories to each other, you know, with how we can imagine how the world works. And we share that with people, and people kind of can, you know, attach themselves to those ideas and take them forward. But we've also sought to kind of, you know, improve the fidelity of that virtual kind of ideas in our imagination through technology. So whether that's through art and painting, so we can now draw and visualize what we have in our heads. We could print them out and put them into words and send that around the world, and people could kind of become access to those kind of timelessness ideas of what's, you know, that kind of virtuality can get passed around more easily. And then to things like cinema and television, where we use a completely different medium to kind of express what doesn't exist or what we imagine. And so each kind of step through this, we've kind of sought to improve the fidelity. And I guess this is, you know, why do we want to do this? And I think there's kind of a few kind of key concepts here. And the reason why we do this is that we want to kind of contextualize what our experience is. And so we can kind of share that virtualness to kind of say, this is how I think we fit into the bigger scheme of things. This is how these things kind of relate, or why they might relate. There's also just that idea of expanding the mind, of thinking beyond the horizon. Like, you know, quite often we're kind of limited with what we can see. The virtual kind of allows us to think beyond that, to think in kind of greenfield spaces, to really kind of imagine what a different world could actually be. And part of that is, it's exciting to do that. It's about kind of having exciting into the kind of mundane parts of our life. the virtual allows us to kind of get excited to go through that kind of fantasy and kind of see what those possibilities might be. And, you know, computing has always kind of been a part of that. Our kind of ideology of science fiction has kind of quite often taken the new technologies and kind of taken us, okay, what could we do with this? And computing's been there since, you know, the 50s, and it's become melded into our science fiction in the way that we kind of think that the future could and perhaps should be. But, you know, science fiction often goes way ahead of what contemporary technology can imagine, the possible futures that computing could actually do. It took a long time before digital environments were capable of doing really anything beyond text or adding up and those kind of simple functionalities. And I think this is a really good example. This is a screenshot from the movie Escape from New York. You know, and for us, it looks very digital, looks very kind of, you know, we're used to seeing that. But the reality is when this was shot, computers couldn't do this. They couldn't kind of construct 3D wireframe environments, even that kind of basic concept. So what they actually did was built a model and then taped kind of that fluorescent green stuff that would go under the black light. And I guess to me, that kind of shows that the technology has to kind of catch up, and we can keep imagining things, but slowly but surely, you know, those little basic things become incorporated into the technology. And the science fiction has helped kind of push forward what we need to do or what's possible. And so where we are now is to a point where computer-generated 3D graphics have allowed us to create purely digital objects. And these things can then be kind of merged in with the real world. And at first, it wasn't really kind of possible to do this in a solely kind of digital means. You know, we incorporated into the existing kind of analog thing. So this is probably one of the earliest and more famous kind of introductions of 3D graphics into movies, the Terminator 2, you know, the liquid metal. And what it did was kind of give a visualization of a concept that was really difficult. I mean, how else would you show a guy that's made out of liquid metal that can reform and transform himself, kind of infinite possibilities? To do that in a traditional way would have been incredibly difficult. But 3D allowed us to kind of start to blend these two ideas together, to bring that kind of virtual imagination into a kind of physical world. And at the beginning, it was really that kind of blending, and, you know, it was limited to the movies because no one else could actually afford to do any of this stuff. That this took, you know, hundreds of man hours to actually create. You needed the most expensive, fastest computers to actually go through and render this stuff, and stitch it all together. So this is kind of how we kind of evolved out of that. And, you know, it got to a point in terms of the technology where we could actually start to render those 3D environments. But, you know, this is kind of I guess a screenshot of kind of the early days where they were really kind of low fidelity, very blocky polygon shapes. But all of a sudden we were starting to deal with kind of this 3D space and this 3D environment. But as processing power increased and we could add animation, and eventually whole worlds could kind of be created. And today's 3D worlds are really ubiquitous across kind of gaming and in film. And the technology has kind of reached a point where it's not only realistic, it's stunningly beautiful. So these shots are actually game shots, in-game shots from Grand Theft Auto 5. So this is kind of the fidelity that we're capable of now producing in terms of that 3D environment, that computer, that digital, that virtual kind of imagined space. It's now possible to kind of do these highly realistic kind of shots. You know, this is thousands upon kind of thousands of pixels showing kind of, you know, smoke and fog and clouds and water and all those kinds of things. And so we've kind of got to a point in terms of this virtual space where it's becoming, you know, quite difficult to actually distinguish between what's actually imagined and what's real. And so, you know, now all of a sudden this kind of virtual idea is kind of a little bit interesting because we can make it look really realistic. And so we're kind of meeting a bit of a crossover point between that kind of virtualness and the kind of fidelity side of things. So how did all this happen? Well, the underlying technology is 3D, and that gives us the ability to actually map and create objects in space across the 3 dimensions. So most of you are kind of familiar with the X and Y axis of the graph. That's a pretty standard, that's the 2D. And then what we do is we add the Z axis, and now all of a sudden we've got this kind of extra dimension to play with. And now we can kind of give stuff space, we can place them in a space, we can give them volume and dimensions. So when it first kind of started, we were creating these kind of singular objects. We kept them very simple, that kind of polygon kind of base. But we've been able to kind of make them more complex. And once you can kind of create one object, and then you can have the power to kind of add them to 2, then all of a sudden you can start to create context and situate objects within a bigger environment. And so the number of items that we can get to coexist within that environment has steadily been increasing. And we can then add more complexity to the actual models themselves. We can give them physical properties. We can provide them with data about how they might interact, how they might move and flow. And we can animate these things computationally. So rather than the kind of old school kind of cell animation where everything had to be hand drawn and hand tweaked, we can actually set these as properties. And so that when objects in the 3D space start to interact with each other, then they actually animate themselves. But the main convention that we've kind of been dealing with is that we've been stuck with viewing these visuals in this virtual environment through the screen. So we're looking at a plane at an imagined reality. It's only ever kind of lived on that screen. It's stuck behind the glass. They may be beautiful, but essentially they're still kind of that unattainable because we have to kind of look at them on this plane. But I guess, again, this is where that technology is kind of evolving. It's catching up to kind of the ideas. And now what we can do is we can strap on some goggles and really actually immerse ourselves in a virtual world. We're not necessarily looking at a screen anymore. We're looking through the screen. The goggles actually take away the rest of the environment. We're looking purely at that kind of virtual space. And virtual reality is not anything kind of new. It's kind of been an evolving field since probably the 50s and the 60s. But, even that kind of first kind of 3D environments that got popular in the 90s, they were really blocky. They were that polygon kind of thing. But it kind of laid the foundation of, how could this technology work? And it's been getting better and better as we've gone through. So now, because we've got that fidelity within those 3D environments, we can actually, replace our viewing experience of the virtual world with something that's much more natural, much more realistic. And the beauty of the kind of goggles is that, if it's on a screen, you turn your head, you're looking away from the screen. When you've got the goggles on, you turn your head and you're actually looking around the environment. You can change your viewpoint. The goggles are really tracking your field of view. And so it's, you're getting this first person perspective of things. And that's kind of, something that's quite new. And I guess just as a side to this is that it's not necessarily just applicable to the kind of virtual 3D kind of objects that we create. Things like 360 video are the similar kind of ways, is that we can create a digital kind of space to operate in, but it's recording the kind of real world. So it's not something that's just imagined and just virtual. The same technology can be utilized and to kind of engage with 3D, real environments. So things like 360 video, like Google Maps and Street View, I think you can actually get in and have a look at and see and interact with by using these kind of goggles. Now, it's also kind of important to point out that we're a long way from the Matrix when it comes to virtual reality. I mean, what we're talking about here is... It's an interesting one. What we're kind of looking at here is we're a long way from kind of getting in and doing anything beyond just the visual components. The interactions are kind of done with kind of hand controllers. That's still a kind of a little bit awkward, and there's not necessarily any feedback when you do interact with objects in the 3D space at the moment. We don't have that kind of technology coming through, but it's something that's kind of coming through. The next kind of wave of technologies can really kind of prepare us for that. But I'm going to play this little video, and I hope it kind of comes through okay. But this is what's kind of possible now, I guess, in that 3D space. So this is zero latency. It's a kind of game that you can go and play in Melbourne or Sydney or Brisbane. And basically what you do is you wear a backpack with a computer. You have the virtual goggles on and you get given a gun. And then you get to walk around in an actual physical space, which is just a kind of clear warehouse room. And you get to kind of interact with the virtual space in the physical space. You're not kind of tethered to a computer. You can actually walk around. And what this is doing is kind of tracking your motion through the space. And the beauty of this is that they can kind of construct new maps and new levels. You can walk up and down things in a virtual way, not necessarily a physical way. And so this is kind of, I guess, really exciting to think about, having this kind of technology to really immerse yourself in that kind of 3D and virtual space. But at the same time, strapping a set of goggles on isn't necessarily the most practical nor useful way of interacting with the kind of virtual. And so that's kind of where augmented reality comes in. At this point, what we're doing is kind of using our phone as a window to look at the virtual space. And the reason why this is possible is that mobile phones provide us with a digital object in a physical space. These things are packed with a whole range of sensors. There's gyroscopes, GPS, microphones, and cameras, which actually allow it to sense the world around us. And this allows us to kind of create a map of our physical space and then transform that into a 3D virtual environment. And this is where things get interesting, because once we've got the map of the physical environment, then the digital can get mixed in with it. And we can start to actually blend in and attach virtual objects into physical spaces. So AR has been around for quite some time. It's been around since, most of the kind of smartphones kind of came onto the market. 2010, there were already people kind of playing around with this. But the big advances have been that it's now kind of baked into the operating system. Both Android and iOS now have this as a core component of the operating system, which means that it's supported at that kind of hardware level. It means it's more accurate and it's more supported on more devices. It becomes kind of like text messaging or the camera itself, your ability to actually engage with this kind of augmented reality. Now, to talk about augmented reality, I think there's kind of three kind of key kind of components around this and three functions of augmented reality that are kind of really interesting to explore. So the first one is displaying the virtual. So this is being able to kind of put those virtual objects into a physical space. The next one is to look at how we can use the tracking of objects within the phone to overlay them with information. So bring in digital sources and extra information. And then this idea of kind of extending the physical. So you've got a physical object, but could you make it smarter? Could you do more stuff with that object? And you can do those kinds of things with augmented reality. So again, this is just a video. It might be a little bit kind of jumpy around, but what you're looking at here is what Apple kind of demoed back in June, the developers conference. This is coming out in the next kind of iOS update. But essentially what we have here is like an Angry Birds style game where you've got two players, they've got slingshots and they can knock down the blocks in the middle. And what we're seeing here is really interesting because they're all looking at the same thing. We've got three kind of iPads set up, the one that's actually doing the recording and the other two. And what we're all looking at is the same kind of virtual object. And you can see here that they're kind of knocking over the blocks. They're actually interacting with this together. This is kind of really interesting stuff that we're not just we're bringing in those kind of virtual ideas and putting this onto basically just a clear table. But all of a sudden now people can actually interact with those 3D virtual objects. You can all see it at the same time. You can all look at things in situation. And there's been a whole kind of variety of apps that take advantage of this technology. There's anatomy apps, so you can kind of see here's a body or a hand on the table and then start to kind of peel back the layers and look at those kind of 3D models there. IKEA have, and other companies have actually got furniture apps that are building out the catalog. So now that you can actually go through and place the chair in the room and see what it looks like before you go and buy it. There's some really interesting videos that I'll kind of link to, but, you know, using AR to actually hijack spaces. So there's a video of MoMA in New York where what they've done is use the objects in the room to kind of hijack the artworks and put new artworks in there via augmented reality. So all of a sudden, this idea of displaying the virtual can really extend the purpose of a space. We can start to rethink, you know, what's possible within those physical worlds by adding stuff from the virtual space. The second one is overlaying information. So I've got two kind of clips here. So the one on the left, the kind of vertical portrait one, is basically looking at the skyline of London and then overlaying the kind of points of interest as you move the camera around. So this is using that kind of object recognition to kind of say, oh, well, that's this thing, and here's additional information about what you're looking at. This one here is for anyone that's ever had to do tech support for parents or older people. You know, you're trying to show them how to do a complex process. Well, now what you could do is use AR that, you know, Nana can pick up the remote and actually see those kind of instructions in place. They're not like wondering which red button am I pressing. They can see what the process is. And we can use this kind of functionality to kind of explain things, to provide context to objects. This is another kind of example of this, of, you know, using the physical object to kind of bring in extra information. So here we've got a game off the shelf. We look at it through our phone, and all of a sudden now we can see here's the price of that item at different stores. Here's video clips of the gameplay. Here's the review. Here's extra screenshots. You know, you can start to think that using this overlay can actually add a whole bunch of additional information to a physical object. Or even things like our textbooks or like the materials that we produce, we can provide students with extra information about those kinds of things. And then this one is looking at extending the kind of physical object. So on the left, what we've got is 3 pieces of paper. They've got different things printed on them, but what we using AR here is to actually, you know, you recognize those objects and then overlay moving pictures and information about them on top of them. So we've got just normal bits of paper. There's nothing special about these actual physical objects, but now we can kind of overlay them. We can put new information on them. The second one is looking at the Apple Watch. So on here, you can kind of see the icon, and the AR app can actually recognize the icon that's on the watch and then display additional information based off recognizing what it sees through the camera. So all of a sudden, you know, you can extend the physical kind of nature of these things. Instead of having to interact them with a special way, you just overlay them with a kind of whole new kind of environment there. And I guess this brings us to the next kind of area, which is the mixed reality. And this is essentially blending both that kind of virtual reality and the augmented technologies. And so you're doing this by putting on a headset, and it's allowing you to kind of physically map out the room around you and then to display things by looking through the glass. So if I just play, this is a kind of promo video from Microsoft around their technology, which is called the HoloLens. And so what this has actually got is a couple of cameras on the front, and then you can actually see through the glass. And so you can actually, these are projections on the real world. So you're still able to see the real world around you, but at the same time, the application then can project these kind of 3D objects into that space. So you kind of got the best of both worlds. You're using the physical world to be anchors to those kind of virtual objects. You know, it's mapping out what's a flat surface, what's a wall, what's that, and allowing you to kind of overlay things. But also, you know, what they've shown here is because you've got a camera, you can make like a Skype call, and the other person can actually see what you're seeing. So that kind of idea of kind of being able to immerse yourself, see what a practitioner is doing, or to ask for help, what do I do now? You can actually annotate like that screen. So if you're asking for help, you can actually say, I don't know which button do I have to press to do this. Someone can actually annotate on the screen, and you can see that on the actual object that you're looking at. So that's kind of, you know, really interesting kind of potential to go down that way as well. So if we think about those kinds of technologies, how exactly can we use these in education? And I think essentially what we're kind of putting on the table here is a bunch of new immersive technologies. We're not really kind of looking at stuff anymore. These are things that allow you to actually interact with them, to touch them in some kind of way, but to kind of do more than just simply consume them or to read them or to just look or watch. We can actually kind of get in there. Like the idea of kind of being able to actually change the perspective, to change the point of view. I want to see these details from this kind of direction is really a kind of interesting way to kind of think about things, to kind of get immersed in entirely kind of constructed environments. And this has some really kind of interesting, ways of doing things, because at CSU we do kind of have this pride about, educating for the practice of practice-based education being part of what we do at CSU. At the same time, we know that that's essentially really difficult to do because of the kind of constraints of sending students out into the real world. But being able to kind of engage with a virtual simulation of that real world, of those real situations, could be really empowering for students so that they're kind of geared up before they go out, and it's not necessarily having to learn everything on the job, but they can learn while they're on the job or beforehand. Particularly those kind of mixed reality and augmented reality is, learning stuff while you're doing it, being able to kind of pull out a phone and see and get directions about these are the steps you need to do. Quite often what we do is when we teach for every possible eventuality, and then students out, and then they so kind of bombarded with information they probably forget half the stuff that they did, or they don't use a lot of that information. And that's partly because, coming back to this slide, is that idea about kind of contextualizing stuff, to be able to kind of share that information, to kind of provide context for information. It's not just here's every possible situation that could arise, here's specific information tailored to you in that specific environment with that context. At the same time, again, we can use it to expand the student experience. We can take them kind of beyond what's possible within the kind of physical and even the kind of practical sense of things. Sending students out to go and make mistakes in a virtual environment means that they don't do it in the real world. And that's kind of what's driven, the pilot simulations and flight simulations for the, past 20 or 30 years, that they've really kind of harnessed on that, because you don't want them making a mistake with a, couple of $1 million bit of aircraft. But I think, that's this idea of being able to kind of, expand what's possible, to make mistakes, to do those things in a virtual space where it's safe, is really kind of interesting. And then the other component is that this is probably much more exciting than reading a textbook. And so that ability to kind of engage with students, to kind of bring them in, to kind of excite them about the thing that they're doing, rather than it just be, here's a diagram, follow step 1, step 2, of being able to watch it, to see it, to kind of happen in real time, to be contextualized within the thing that you're actually doing. So, like the kind of remote control thing where here's step 1, here's step 2, here's step 3, having those objects in your hand and getting that kind of guidance through it, rather than reading the kind of step-by-step kind of instruction boxes and panels that are happening. So that's kind of, I guess, my little overview of what we kind of hope to be kind of covering from here. So this is really just the start of the season. And so it was really more just to give you some examples of what's possible, to introduce that kind of foundational ways of thinking. We've got the hashtag and our Twitter account, which is kind of where we'll be updating things. So if you want to kind of contribute into the discussion or conversation in those spaces, that's the information you need there. We're also, I guess, putting in like a readings list of stuff that's articles that are related to the topic, but also somewhere where we can dump all the kind of links and things that we've been showing. So all of the stuff that I've got from, I've shown in the presentation today is all in that reading. So you want to watch any of those videos in proper kind of high def, then that's all possible instead of it being so juddery. And that'll be kind of an updated document. So it's just a Google Doc. You can get in there and access it. And we'll continue to kind of add throughout the season to that document. So that'll be kind of a living thing that people can kind of do. And I think you can go in there and comment on it as well. And I guess this is kind of, where there's more stuff coming up. We've got on Thursday, virtual reality in the teaching of anatomy and physiology. So that'll be kind of really interesting to actually see this stuff getting used in practice. And then the other kind of thing we've got is these drop-in sessions going on throughout the season, where you can actually we're just going to have the Zoom meeting room open, and anyone can kind of drop in, have a chat, ask questions, think through some ideas of how this might work for them. That's just an opportunity we want to kind of provide to people, rather than kind of feeling isolated and no one else to talk to. You can come and talk to us. And if we get a group of people, that'd be fantastic to have a kind of conversation with everyone. So I'll leave that there. And I haven't checked the chat, so I'm assuming there's a heap of stuff in there that can probably...
Okay. Thanks, Tim. That was fabulous storytelling. I did enjoy that journey very much. And it was a really nice way of providing a nice context and foundation for our We Imagine mixed reality season. I'd like to open now to the floor for questions. You can type questions in the chat if you like, or feel free to use audio to ask your question, or even just make some comments or observations.
I'll start. Thanks, Tim. Really great to have this on the radar here at CSU. I guess my thought with all this is it's going to be really interesting to see some of the actual examples, and I've just got the awareness of this both extending the student experience, but also has the potential to increase the gap in disadvantage between the technology haves and have-nots. And also, in terms of, we've got students who still struggle with broadband, and then we've got people who are in 5G trial areas, for example. So just that full continuum of the experience is something we need to consider as we look at these things more closely in the coming years and they become mainstreamed, and the cost and who wears that. But it's a really fascinating topic. Looking forward to it.
Yeah, I think that's really kind of important, is that we're really at that kind of early stage thing, that a lot of this stuff isn't necessarily consumer ready, like particularly in the VR space. Like the HoloLens things, I think started about $5,000, so that's kind of off the radar for most people. But the thing particularly with augmented reality that I think is really important is that it's on your phone, and like that's ubiquitous technology today. Most people can kind of start to interact with it at that kind of low level. And just the third kind of presentation there, which is, using AR in the actual web browser, I think that's really important as well, that we're starting to see that it's not proprietary. You can do stuff with free tools. You can get out there and start to experience this at kind of that lower level. And if that brings people in, I think that's a really good start. But at the same time, we're seeing this kind of much more high fidelity kind of stuff that people can kind of use in terms of the VR. And I think that stuff is, again, that's one of those interesting ones where the price point's going to come down. To what, I don't know. But I think it's one of those things that it might still be, you go somewhere and experience that it's a shared kind of resource or asset, rather than everyone has to own their own thing. And so maybe it's kind of like the internet cafe back in the day, where not everyone had the internet, but you went to a cafe and you used it there. And I kind of assuming that might actually be a case for the virtual stuff, because it is really expensive. But you go to an actual shop or a storefront and then get a room and you go and play with VR in the confines of your own room. And I think I even saw one of those in Melbourne recently, where there's like karaoke bars and reality rooms.
It's got really interesting potential to make our on-campus spaces much more relevant, which will be ironic that, like you say, we can have stuff on phones, but also have these really high-end spaces set up on campus one day, perhaps. So, yeah, really cool. Thanks, Tim.
Yeah, thanks, Jed. Any other questions or comments?
So, it's Kath Hatchery here. I just wonder, do you have any examples in business? I can see anatomy and physiology. I'm just trying to think, how could we use some of these in a business context? Because it always helps to like get your head around it when you've got an example.
Can we be a bit more specific than business?
Okay, so all right, let's just talk about something like, I don't know, managing people or leading teams, or even if you look at marketing, it could be market segmentation, target marketing, something like that.
I think there's, I mean, I don't have any kind of examples off the kind of top at the moment, but I think the idea of kind of being able to overlay kind of information and provide that kind of context is really interesting. So if you think about, say the share market or something like that, and, within your textbook, you might want to have, here's a snapshot of what the share market is. But instead of it being just a static object, being able to bring in real-time data and display that on that object is really quite interesting. So I do have an example, I think it's in the readings list, but about that shows a newspaper. And so you've got a newspaper which is a static printed object. It's not going to change. But at the same time, using AR, you can recognize the layout and then actually overlay those objects. So instead of just having the still shot of the final kind of goal that was scored, here's the video of it.
Yeah, okay, yep. And maybe now I'm thinking of things like some of our international management or international marketing. Maybe it's about having some sort of immersion in a street scene in Asia or something like that to kind of get the real feel of the difference and what it looks like and what a retail outlet looks like, or an office, or what people are wearing, what cars they're driving.
Well, even looking at some of the things around like the fittings that are in shops or the systems that they're using, and being able to actually recognize those things. So you could walk into a shop and say, you want to kind of improve the costs. It's like you could look at the shop and it recognizes, hey, you've got fluorescent tubes and not LED. So there's a cost saving to do that. Even looking at actually measuring the space, which is now possible. There's a bunch of kind of just measurement apps that are available on iPhone and Android now, where that's what it does. You can say, here's an object, tell me how big it is, and it can recognize that. So in terms of kind of retail outlets, being able to kind of map out spaces to say, this is optimum kind of walk through, and this is maybe where you want to market or place certain objects. I think this is kind of really a starting point, and it's kind of going to be up to us to kind of come up with some of those applications.
Yeah, okay, great.
Hi Tim, hi everyone, thanks. Just to add to that, Kath, I just read your name on the screen. My daughter goes to University of Newcastle, and she is doing graphic design, and she showed me her virtual reality assignment she had to do, which was basically she had to design wayfinding around the building. So she had to go to the site, take the photos with the special stuff, and then overlay her designs for signs for where the bathrooms were and the reading areas and so forth. So then she submitted that as her task, and students as well as the lecturer could then walk through the building and see her signage overlaid, and that was a really effective way to bring that assessment task to life. So I think that's the other thing, we can get students to do this. I'm thinking of products. They can go in and photograph products and overlay them with information similar to what the Vivino app, which I just put up, which I love, because you take a photo of the wine bottle label and it'll tell you about it. You can rate it and how much it costs. So, that's sort of getting the students to generate resources using augmented reality.
Okay. And I can see the application of that in terms of the core product, the whatever the actual product, and the augmented
and walking
product.
through a supermarket, that's a virtual experience.
And that would be very interactive. They just go and take a picture, and then they expand on it and just say how that they would improve it. Okay.
I see there's just a couple of questions about just the idea of kind of accessibility with these kind of formats, because we have, what we're talking about here is essentially visual kind of mediums and things at the moment. But I guess it's quite interesting to kind of see some of the kind of technologies that are coming out of that space. There is a few apps that are out there that basically use the camera on the phone to create like a digital map that can then be fed back to the user via audio. And so some of them are kind of complex in the sense that what they do is provide an audio map. And so using something that's kind of like the equivalent of radar or kind of echolocation, the phone can actually construct an audio map that a blind user can actually use to see the world. But also just in terms of being able to kind of, see what's happening or get a commentary of where they're at in the world, what's by, that idea of those kind of points of interest, what's near me, and being able to use the phone as that kind of interface to do that stuff. It's not necessarily, kind of answering the question about all the other applications, but I guess there are some really interesting specific applications that make the world a little bit more accessible.
Yeah, I understand. Yeah.
Another example I came across recently was I was doing some work for a water authority, and they were commissioning to get pumps that they were thinking of installing in their pump stations developed in AR, so they could then take it to the space within the pump station and work out whether it actually fits. All the asset management data fed into that graphic, so they could work out whether the valves were going to be suitable for the pumps, and explode the views and check that everything was going to fit in there. And it was really interesting stuff.
Yeah,
and that's actually happening now. That was only a couple of months ago.
Yeah, and look, the HoloLens that Microsoft have kind of developed has a few of those very specific applications of being able to go and then drop in your virtual models and see that layout. And that's kind of in their little sales videos that they've got out there. And for those people that can afford it, it probably is a really massive kind of time-saving and labour-saving tool, and they can justify spending $5,000 on a headset.
I think they had to spend the money before the end of the financial year.
But it's really interesting, and I guess that's the thing, that price point is one of those things that's probably going to fall, and that technology might evolve into something else that's less kind of cumbersome. So yeah, I think it's kind of definitely a watch this space, but it's still very embryonic, but I can really see how we could really use that technology.
Yeah, I can see there'd be applications too, even with like search and rescue with that kind of technology. So while it might not be a price point that's going to be for a student or somewhere in their own home, I can see business, I can see emergency services, I could see defence quite easily being using those. So when we're thinking about the context in which the students that we have coming through university, it's not just about the application of the technology. It's, we've probably got university students now who are actually have and are developing the skills that can actually be helping move this technology to the next level. And so I think that's really exciting as well. So from the people that are working in the media and production, and also working in our, like our IT disciplines at CSU as well, I think there's some, and just the whole gamification kind of market that's out there. We're probably looking at, a generation of university students who are going to be creating the next level of this sort of technology. I think it's interesting with the session that we've got coming up next Thursday by Alex Young, who works for All Media. Their web browser platform, I believe, is the first web-based augmented technology, and that's Australian made, but the majority of that work that they're doing is being done in the United States. So businesses are surely hungry for this kind of technology. And it will be interesting to see whether the appetite for the technology is the same in higher education, for example, because I actually think K-12 sector has an appetite for this kind of technology to support learning. And so this is a really fabulous season for us to be exploring at this point in time, given how quickly the technology is developing in this area. Does anyone else have any questions or comments? We've got about 10 minutes, and the idea of these sessions was to leave time for sharing of ideas, bit of brainstorming, and asking questions. So please feel free.
I was just going to say then, I mean, I guess in the presentation as well, that was very heavily focused on kind of headwear kind of thing. But the reality is that this technology could be applied to anything that could be a display. So if you think about like in the car, having a heads-up display where you could project like the digital or the virtual kind of things onto the screen, onto the windscreen to kind of see what's out there, or even like on a train, on the window, being able to kind of see what am I looking at out there. I mean, all of these things could potentially be how we see this stuff. It's not necessarily something you have to whack on your head or hold up and look around. And when you think about that, then you can see some of the kind of very specific applications like of driving, of being able to find out like, you know, heads up of this is the direction, these are the things, points of interest that you're driving past. There's a whole lot of kind of contextual information that could be really useful as a driver. But then you've got specific drivers like ambulance drivers or police that, where's the fastest way to get through here? You know, is there an accident up here? What can I do? You know, those kinds of things could be, you know, really important, and it's all using that same kinds of technology that we're talking about here.
Yeah, and it makes you aware of the information that is surrounding you, isn't it? Like whether it's a supermarket, whether it's I was just thinking the other day when we were talking about developing our augmented reality program, where, you know, if you were here in Canberra, for example, if I was walking past Old Parliament House and all of a sudden pops up on my phone all of this information about what is currently happening in Old Parliament House as I'm walking past there. So what exhibits, the cafe, you know, there's a lot when it comes to tourism. I think that there's lots of potential in overlaying that information with buildings and spaces. So that whole sort of place-based learning then becomes really interesting as well. And so if we start to then think about what disciplines at CSU are working in the field, for example, I think then we're starting to see some applications there. So whether it's viticulture and a range of agricultural applications as well. Just the other day when I was having a conversation with someone who used to work in the tractor industry, and we were talking about augmented reality. And I was saying, well, you know, you've now got augmented apps where someone could be in the workshop in Sydney or something, or in Wagga, and there could be a farmer who is way down the back of their property and their tractor's broken down. And the technology will now allow a workshop mechanic, for example, to be able to show on his phone how that farmer can be fixing his tractor in his field. But I think the 4G and moving into 5G and having the bandwidth to do that is still an issue for us being such a large country. But I just think there's a lot of applications technically that certainly can be supporting disciplines that are being taught at CSU. So this season is really about thinking about the possibilities, and, you know, really kind of tapping into our imaginations about the ways that we could possibly be able to utilise the power and potential of these technologies to support not just teaching and learning at CSU, but supporting the disciplines and industries within which our students are actually learning.
Yeah,
I think it was really good to see you put the ethics on the agenda, because anyone who's, and also the fact you just were talking about, it's not just about lenses. I think anyone who's spent 5 minutes looking at this would have seen the term, you know, excuse the language, but a glass hole, when Google Glass came out, about that receptive and proactive, you know, dealing with the incoming information and privacy concerns and stuff like that. So that's, alongside of that is the potential for this to drive further commercialisation of education and what that means, because like Nicole said in the chat there's some really huge potential in terms of history and geography learning. But, you know, a developer in this space, you know, could charge $300,000-$400,000 a year pretty comfortably, and who pays for that, and how do you get access to that kind of resourcing in a cost-constrained environment like we're in? They're just all really good questions to have on the radar.
Yeah, I think content, the development and provision of content is a challenge. And and I think that's, we're even seeing that in other spaces now, where publishing, large publishing houses are moving into online learning module content that they're trying to sell, because they're constantly trying to find new ways to expand their market. I think and probably Alex Young's presentation, we've got 3 different industry representatives presenting as part of our season to give an insight into what's happening in the industry and how they're designing and changing and developing their technology to support the shifts and demands that are being placed on these developers of these technologies from industry, from education. And I think when it comes to the idea of the All Media app, is that coming back to the consumers can be producers or creators. So it's putting the technology in the hands of people who don't have the skills to code and develop, but they may have the stories, they may have the artifacts, they may have the objects, they may be working in a place where they can be capturing the information about those areas and actually putting it into an app. So I think, and that's probably what I find most interesting, is putting these sorts of technologies like the web-based app development tools into the hands of our students and seeing what they can create.
I think I was down in Adelaide a couple of weeks ago, and there was quite a bit of discussion around like just the 3D kind of models and how that works. And there was a guy there talking about how they were investing in, I think it's a $5,000 kind of rig, but essentially that allows them to kind of create 3D models of real objects. And so discussions with kind of, museums and that have kind of artifacts, and then the potential to literally kind of send that out to students wherever they are. Like you're just emailing out, here's this object, you can now have a look at it. Digitizing collections, digitizing objects. If I think about, there's real potential in things like health, of here's a model of this, taking stuff out of, an MRI scan and reconstructing it as a 3D object. Here's what that condition looks like. This is what that looks like. And you can see it, you can twist it around, you can, spin it, see it in bigger than normal. I think that's kind of going to be the next step, is maybe looking at how do we digitize those things around us? How do we create the models so that we can do the next step, which is using them and doing it? Because I think that is still particularly when you're talking about virtual stuff, that's the biggest expense, is really just creating all the models that are required to populate it. The software to actually do it and design it once it's done is actually quite cheap or free in a lot of cases, but you need the models to kind of populate it. So I think that's kind of going to be an interesting kind of challenge, and maybe where universities set up, because the expense of putting in a 3D scanner might be too much for everyone to have, but maybe on a campus that might be a really good place to kind of house that equipment and allow people from not just the university but the broader community to get in and use it.
Yeah, good idea. Okay, any final comments, questions? Well, I must say I've really enjoyed this session, and it's the first of many. Lots of ideas shared in the discussion, which was great as well. Thank you everyone for attending. The recording of this presentation will be made available on the UImagine website along with other objects.